Thanks, Eugene. Hello, everybody. As Eugene mentioned, today we're going to have a comprehensive overview of the new features in Adams 2016, both in terms of general features, including some of the ones Eugene mentioned already, as well as then some of the vehicle product-specific features. So I'll take us through each one of these. We'll start with the general features. So in this release, we've added the capability to switch the type of body from rigid to flexible during runtime. So this means from a rigid body to a linear flexible, M&F-based flexible body at any point during the analysis. This is important and helpful when you're trying to reduce your simulation time, say for a portion of the event, like the deployment of the landing gear. You don't really need the flexibility of the system, but then when you bring it down into the ground hard, you're going to need flexibility in those struts. And what we're seeing in the plots here is that the results track, the hybrid results track the rigid results pretty closely during the rigid portion of the event, and then in the flexible portion of the event, they track very closely the flexible results, and you get a faster time than keeping the body, a faster solution time than keeping the body flexible the entire time. The rigid body representation of this is really the flexible, you're still using the M&F in the model, but you're simply setting it to be treated rigidly. And for years, that did not perform so well relative to a true rigid body representation, but since about 2012 or 2013, I believe, that performance has been improved to be nearly equivalent with true rigid body performance. So it's a good rigid representation in that case. And there's no extra pre-processing steps to really switch from rigid to flexible. You basically set up your flexible body the way you want it in the model, and then so one click to switch it over to rigid. Okay, Eugene mentioned an interface that's capable of working with Excel. This is what we're calling Adams Explorer. And this is the spreadsheet interface for Adams View and Adams Car. So what this really helps us do is enable non-Adams users to exercise an Adams model from Excel. Many users, Adams model users, could do that as well. The Adams user is in control of what goes into that spreadsheet and what things we want to expose in the spreadsheet to the non-Adams user. And then the model values could then be set from the spreadsheet, and analyses could be run from the spreadsheet as well. We'll get into that in a little more detail, how that looks. So from within Adams View, this is found in the Design Exploration tab, and we can export a model to the Explorer workbook, picking things like design variables, hard points, mass properties, functions for motions, spline data, and then we also have an analyses tab where we can set up the analyses, specify essentially which specify a number of analyses. Which simulation scripts do we want to run? Which plot configuration files do we want to enable with each of those? Do we want to run and generating plots against each of those analyses? And then up here, there's also a capability here to specify an analysis machine name and the Adams View launch commands for that machine and for that installation of Adams. And what that does when you export the spreadsheet is it sets up a tab in the spreadsheet where you're able to then launch that machine, assuming that machine is successful on the network from the Excel user's viewpoint. So what I'm going to do is get into another example showing this from Adams Car in a little more detail, and you can see a little more detail about launching runs from the Excel spreadsheet and setting up the spreadsheet in a little more. So what we're going to do in Adams Car is run an Adams Car analysis, just this sedan going over a pothole and changing some characteristics of the vehicle and seeing how those results change. So we start in Adams Car with an assembly that we want to work with. Could be a full vehicle, could be a suspension. We go down here to the Explorer menu and say we're going to export to the workbook. And from there, we're going to set up some details of the workbook, name it, which assembly we want to be using, which assembly in our session we want to be using. And then in Adams car, the things we can select are a little bit different, car type objects spread across the subsystems, different hard points, different mass properties, parameter variables that are involved in the vehicle, as well as user-defined specific parameters on user-defined elements in each of those subsystems. In this case, the Adams analyst is thinking, well, I'm going to export some details about the springs and dampers. I'm doing a pothole event. Maybe the springs and dampers are going to be important, something I want my colleagues in engineering to tweak a bit. So he's exporting damper splines and damper parameters, specifying that the spreadsheet will be populated with damper splines and damper parameters when we do the export. So going again through picking these items in each of the subsystems that are of interest. In this case, again, the left and right, front and rear dampers splines for the rear suspension here, and then the front suspension. And then once these values have been populated, we can also select property files if they like. And it may not be something that all the folks, the non-Adams users, are familiar with, but which ones? But maybe they are. So we can pick here some tire files if we want to instruct the user to switch out to different tire model, perhaps. And now, from an output standpoint, we're looking at design objectives. We want to study the pitch angle of the vehicle, so there's some design objectives about the maximum pitch angle, et cetera. So he selected those, and then now he's setting up, as I showed in the view screen as well, similar screen here, setting up defining the machine in which these analyses can be run, a network accessible machine in which these analyses can be run, defining the event, instead of a simple simulation script that we have in View in Adams car, where the event definitions can be a little more involved. So we can set up the driver file, the road file in this case, a plot configuration file like we showed in Adams View use case as well. And now the user is going to then export, click OK and export this workbook and email that, say, to a colleague in engineering. The other thing that goes on is somebody, be it the Adams analyst or perhaps somebody in the IT department managing the machine that's going to run this, would need to set up the job server and a web server, basically launch it from the machine. This could be the analyst machine, could be some machine dedicated for this purpose. So that's done as well. So that's now that machine is up and waiting for requests from the spreadsheet. So now the spreadsheet user, say an engineer not familiar with Adams perhaps, or very familiar with Adams, has got this spreadsheet emailed to her. She's looking at this from her colleague in the CAE group and saying, okay, I see we've got, these are the values that are in the model right now. This is sort of the baseline representation of the model right now. She's going to look at each of these tabs, corresponding to those tabs on the export dialog. Hard points, look at the parameter values, the mass properties, some component design parameters, splines represent essentially the XY curves that represent the springs and dampers, and those things come in here in XY points as well, or XYZ points if they're 3D splines, as well as the plot. So they can easily visualize these things, and then they can move over to the Property Files tab, look at those tabs. Now those are going to be specific to, in this case, specific to the car database that was used. And look at the design objectives that are there, and look at the types of analyses. It doesn't have to be just one. There could be a pothole, and then I want to run a steering event or a ramp event or some other events. In this case, we're just going to do one. So she says, fine, that's great. I want to simulate this. I go to the Adams Explore Server tab here in Excel that's loaded by a one-time plugin. Say launch that analysis, it goes off and runs it on the server, and now she can look at some of the key results. You can see there the design objectives say we get about a maximum 7-degree pitch angle. We see that as well in the plots that were plotted automatically based on the plot config file. Also, the X, Y points of those plots are in those tabs, so the user could do more post-processing on the data in Excel if they like. In this case now, she says, well, it's a little bit too much pitch angle for my taste. I'd like to see what happens if, say we just stiffen up the stiffness of the springs and the dampers by a factor of about 1.5. So that's why I put those scale factors in there. Alternatively, she could have just messed around with the Spline data, edited that Spline data. So now she goes back here to the Adams Explorer Server tab, says I'm going to submit the job. She can stream status here, so about every 5 or 10 seconds it updates the status. It says, well, is the job running or is it completed off on that server somewhere? She says, okay, hey, it's done, great. I can now pull down the completed workbook, and now I can look at the differences in the design objective values from one run to the other. Here I can see I had 7 degrees before, now I've got only 5 degrees maximum pitch angle. Great, and we see that borne out in the plot that's here, in the plot tabs. And you can also look at the loads and the springs and the dampers. So that's a trip through the system. Now, one thing that's not shown here that would also be an optional step, maybe the engineer here iterates a few more times. She finds the values that she likes exactly. Then she says, okay, I'm going to pass that back to the Adams analyst and say, okay, here's the items I want you to now be represented as the new baseline, or maybe I want you to do more detailed study with the model around this baseline. This looks good for this event, tweaking these parameters. Could you do some more broader set of studies on that for me from an analyst standpoint, perhaps? Or just make that the new baseline. And in that case, that Adams analyst could then import the spreadsheet and would update the values in the subsystems in the assembly. And so he would have then a new model based on his colleagues' iterations from the spreadsheet. Okay, moving along to another new feature here. The Adams co-simulation interface has been extended to support co-simulation with a bulk material loading and discrete element modeling software called EDEM. So this is a leading DEM software out there. You'll recall the Adams co-simulation interface was launched back in about Adams 2014, and to enable Adams and MARC co-simulations. MARC's one of MSC's nonlinear FEA technologies. Here, in this release, we're working with outside the doors of MSC with our friends at EDEM. In which case, Adams, similar to how we interface with MARC, Adams is going to be passing positions to EDEM. EDEM is going to be passing forces back. In the case of EDEM, of course, the forces are based on these granular materials. We can look at some examples here in the next slides. Heavy equipment is an area where EDEM has a lot of applications and a lot of users. From an Adams perspective, you may be interested to know what the loading path is throughout that excavator, for example, based on maybe coal or iron ore or different types of materials, limestone, whatever those materials are, different conditions of the material. How's that going to influence the load of the excavator? The other thing you may be interested in is saying, well, what's my detailed machinery model doing to the material itself? How does it spill out? How does the pile change when I go at the pile of different design iterations? So that's another key use case that we'd be looking at. Here's another example model showing a mini excavator here rolling with a bulldozing blade on the bottom there, pushing through this pile of material, and what we're plotting over on the right side was the material in the, plot got out of sync there on the right side, but the material, the force on the blade, and then the mass of material that's actually in the hole. Another possibility Adams users might think about is, well, how about soft soil or loose gravel terrain that I'd be rolling over? So this is a case where we've got this all-terrain vehicle with rigid wheels, in this case rolling over and driving through some granular material, laying down tracks, and seeing how influence the material may influence the vehicle's mobility in rugged terrain, loose soil kind of situations. We also have in this release in-cylinder analytical contact coming to us in Adams. We've had two-cylinder external collisions of cylinders represented analytically. In this case, we're now doing essentially a tube and sleeve type contact, enabling that analytically. In general, analytical contacts are better because they provide us smoother contact signals and faster simulations compared to typical Adams solid-to-solid contacts where we're tessellating the surfaces. Moving along, some other enhancements, general enhancements. We have also within the Adams co-simulation interface the ability to launch these jobs via a single click when you're running all the tools locally, at least in this case, as opposed to having to. Previously, we had to be opening several different windows, DOS prompts or shells for each of the different tools, plus the co-simulation interface. So some usability improvements there. Within Adams View, we've added a small utility to remove unused markers. A lot of times, folks, particularly when they inherit models from other people, say, "Man, this model's a mess. It's cluttered up with all these markers that we don't use for anything." Just go through and I'd like a utility to go through and delete all the markers that don't have any, that aren't dependent on anything. So that's just a nice little utility that's in there. Also, there's a toggle for when you're importing a parasolid model to, or parasolid assembly to an Adams model. There's a toggle here as to whether or not we want that to explode out into the multiple parts, each of the portions of the parasolid model, pieces of geometry to be assigned to individual parts, or if we want those to be lumped together in a single part. The solver team has added another knob, another parameter that the user can edit on the friction calculation for, in this case, for the cylindrical and translational joints. So there's a bending factor that would act on the translational force component that comes out of the joint friction. Basically, it's a factor, where that force would be essentially this factor multiplied by torque divided by distance. So this is a new user-specified bending factor. Previously, it was always assumed to be 1. You assumed you're always going to get torque divided by distance as the contribution to the overall friction force. Well, now we can scale that. Previously, folks would have had to do some tricks with other parameters, like the initial overlap parameter, to get that to work. But now they can specify that bending factor directly in the dialogues for joint friction, and that is whenever the bending moment option is selected, in any cases where you want the bending moment to influence friction. And similarly, there's a new argument called bending underscore factor that's been added to the friction statement within the ADM dataset language. The Adams post-processor has added multi-run plot supporting through the PLT file. So previously, the PLT file was sort of set up to assume that all the plots, all the curves on a plot were different quantities plotted against a same single analysis. A lot of times people are running multiple analyses and comparing the same plot, the same quantity, let's say, across multiple analyses. PLT file doesn't really support that. If you exported those things previously, say, the same single quantity plotted across 4 different analyses, the PLT file, when you brought it back in the next time, would give you 4 curves. So here, it's now enhanced to handle multi-run plotting. So there's an option you can toggle on to say, hey, this was a multi-run plot. And so basically, please preserve, maybe the coloration and the line styling that I've chosen in the order that I've chosen it, so that every time I do I want to recreate these multi-run plots, I get the same line coloration and styling that I'd set up initially. The PLT file knows to look for multiple analyses of the same quantity in this case. Also in the post-processor, the 3D FFT now has the ability to be plotted against general output channels. So this is an extension so we can support plots whereby this second independent axis, the z-axis, is an output channel other than time. Previously, these types of plots could only be made against time slices in that z-axis. Now, any result set component can be selected, and so this is particularly useful for plotting against the rotational velocity of an object in the model, which is typical for rotating machinery type applications. Also, Adams-EDEM, we've added the CAD interoperability component that we use has been updated to support newer versions of CAD, the various CAD softwares that we support. Those items are highlighted here, items that have changed since the 2015.1 release. So you can see some version updates and some important CAD platforms there. Okay, moving along, we'll take a look now at the vehicle product features. So a number of things in the Adams car family of products we want to talk about. There's now an anti-roll bar modeling object. So this helps us create anti-roll bars very easily within the template builder and to operate on those within standard interface mode. It's much faster than having to manually build these things, which is what folks have been doing for years, manually building these things with discrete flexible link methods directly or simplified ones even with multiple parts and setting up your own templates for that. There are multiple modeling options here. So there's a simple option, which is essentially two rigid items connected together by a torsion spring. And then there are two more sophisticated methods, one using essentially discrete flexible link. That's what's called beam here, a discrete flexible link, so where you're using beam forces and discretized rigid parts. And then we've also introduced the FE part. This is the Adams native nonlinear geometrically speaking beam object in Adams that we introduced in 2014. So distributed mass, smoothly distributed mass, and geometric nonlinear. And particularly when you've got sharp corners and things like this, that can be sometimes where this flexible link method can break down. You start violating beam theory by having too short of elements. This is a spot where the FE part can really come to this option. And also with an Adams car, we have extended the alignment capabilities. Primarily, this is the adjustable forces in car are now supporting caster angle, where before it was only just toe and camber. Also, users were required to create additional motions and variables to store the adjusted values. In this release, folks can adjust caster angle using an adjuster force set of type caster without creating any additional motions and variables. And alignment configurations can now be specified directly from the event dialog. So you don't have to go into the standard interface or set up the alignment and then run an event, then change the alignment, then run another event. If you want to have a different alignment, now you can just directly from the alignment dialog say, I want event-specific alignment in this case. Adams Car has also added a spline checker utility. So within Adams Car, there's a lot of items that use data splines. You can think about things like bushings, dampers, springs, some of those items that we saw in our Adams Explorer example earlier, for example. So there's a number of these items used for evaluating stiffness and damping. All of those types of splines that evaluate stiffness and damping characteristics in those sort of standard objects can now be checked. And what that means is we're checking these things for typical, say, typical modeling errors that give the solver a problem and may throw errors at runtime. Depending on the component type, you may need to be enforcing that the spline is symmetric, or that it crosses zero, or that it monotonically increases, or that the data is evenly spaced in X, or that the slope monotonically increases, or that there's some minimum slope. So all these things are errors that can be, say an inexperienced user may not be paying attention for, or when you're importing data, you may have some data that's, not exactly clean in that regard. And so this will check all of the splines in a subsystem, or all the splines across an entire assembly, or even across an entire database for you flag areas where you see these problems, and then in some cases it can optionally repair those. In this case, we're seeing a plot where it's repaired a case where, you know, the blue curve, we weren't having a monotonically increasing curve here. The red curve does, and so that's the repair it made. And so you can sort of visually see the repair the spline checker is suggesting you make, and decide whether or not you want to make that change, make that repair. Within Adams Tire, having a couple of extensions. The packet motorcycle tire has been extended now to essentially use some improved handling analysis capabilities by virtue of using the advanced nonlinear transient mode. The tire relaxation length can now have a dependency on slip, as well as there is TDFT support, the tire data fitting tool support for the motorcycle tire, the PAC MC motorcycle tire. The PAC 2002 tire has had some significant performance improvements in this release by virtue of two capabilities here. One, the 3D enveloping contact model on that tire. So this is the case where you, instead of having a single point contact, resolving down to a single point, there are multiple cams or eggs. Sometimes we call this the tandem egg approach. So the tire has multiple of these cams or eggs, circular surfaces that are going to be contacting the road and accounting for contact on the road. Those things now behind the scenes can be solved in parallel, and so that's going to give us improvement when using the 3D enveloping contact model. And then in terms of the road definition, the 2D as well as the 3D spline and 3D shell roads can be converted to a grid road. So a priori in pre-processing mode, you could do a one-time conversion of these types of roads to a grid road, a CRG road, for example, and those typically solve much faster. In fact, we've seen some test models down here. What I'm highlighting here shows the difference between a 3D spline, same vehicle, same event, using a 3D spline road versus using a CRG road with 100 millimeter or 50 millimeter spacing. So you can see those CPU times drastically being cut there. Same applies for F-Tire, going from a 3D spline road here to a 50 millimeter spaced grid road. Then, in terms of the multi-threading benefits, we can see that highlighted here using the 3D spline road, but using the multi-threading option on 3D enveloping contact road, we see some performance benefits. And then here we're really saying we can cut this simulation down in half if we use both of those things at the same time. We say we're going to use a CRG road as well as use the multi-threading capabilities on the 3D enveloping contact tire. We can cut the simulation time down in about half. Also in Adams Car, there's some extended templates and design options have been added, mostly in this case around the steering system. So these give us a broader set of standard templates for these kinds of steering system and different configurations that we can apply. Most of this technology, most of these templates and these design options come from the Adams chassis product family, bringing that capability into car. Also within Adams Car, we have made the assembly composition a little more flexible by adding the add, remove, replace capability for test rigs. So this makes it a lot easier to swap an assembly's test rigs. So the same vehicle model could be used for a number of events like this SPMM machine or put on a tilt table or a full vehicle. So it just eliminates some pre-processing work and helps get the job of setting up your analyses get that job done a lot faster. Elsewhere in Adams Car family of products, we have added point force actuators. So the point actuator has essentially been replaced with this thing, which is now a new, more capable actuator. The point actuator could only model action-reaction forces along a line of sight, whereas this new point force actuator includes that capability, but also adds two new orientation options, moving with body and space fixed, things akin to the general S-force. We are now allowing a linear analysis to be run between mini maneuvers in Adams Car. So in the event builder, when you're setting up a number of mini maneuvers, you can optionally ask for the Eigen solution, a linear analysis in between those mini maneuvers. Within the Adams driveline, there is what we're calling ramp up and RPM smoothing in the dyno. So essentially, folks are trying to analyze driveline distribution of the cyclic irregularities that come from, engine firing stroke. They can define, to do that, driveline users, can define the current engine torque to be dependent on crankshaft angle, for example, over 720 degrees for a four-stroke engine, as well as be dependent on angular velocity and use a 3D spline for that. Evaluating the current engine torque from that type of 3D spline during runtime, the actual value of the crankshaft angle and angular velocity was used. But due to the cyclic irregularity using this approach, that leads to sort of artificial excitations that result in some unrealistic behaviors. So, and then furthermore, the engine torque would be applied directly from the beginning of the simulation, which leads to some undesired initial choices. So what we've done here to resolve these problems is the AC dyno UDE has been enhanced to account for that cyclic irregularity originating from the engine stroke. Specifically, there's a smooth torque fade-in over time has happened using a step function to optionally eliminate initial transients. And then a new state variable has been employed to track the mean RPM value, angular velocity, so that the engine torque that's used is based on this mean RPM rather than oscillatory actual RPM that was used previously. Within Adams Tire, we've updated F-Tire to 2016 2. So F-Tire, the usual F-Tire updates that we do typically with most releases. And then within the Adams Car Ride, there is now hydromount support within the isolator parameter identification tool, the IPIT. So the IPIT, there is an HPIT, the hydromount parameter identification tool, which supports the parameter identification of just the hydromount components itself. But if you want to take a hydromount into the IPIT, there they can take into account the superimposed bushing effects as well as the preload and offset of the bushing. So the IPIT now supports those hydromount objects. Lastly, just a few more comments about the release as a whole. Platform support for Adams 2016.0 is listed here, notably the addition of Windows 10 support. And in terms of the release date, well, as Ejan mentioned at the outset of the presentation, that's now available. There are also numerous, as usual with our releases, numerous new feature examples included for each of the, or most of the features I described today. So you can take a look at those new feature examples, run through some tutorials, learn how to use these new features. Also, I'll mention that the EDEM co-simulation as well as the Adams Explorer capability, the spreadsheet interface capability, both of those items, I think as Ejan mentioned at the beginning, have been covered in more detail in separate webinars during the beta period. Those webinars are available on our website, right, Ejan?
Yes.
Yeah, so you can access those webinars if you haven't seen them yet and you're interested in those. With that, I'll stop talking, turn it over to Ejan, and some questions and answers.